Hi there, so in this video we're looking at partial fractions again, but this time we're looking at improper algebraic fractions and how to turn these into partial fractions. So what we've got here is what we call an improper algebraic fraction because the numerator, we got on the top, has a higher power of x than the bottom. So this has an x cubed term, but the bottom only has an x squared term. So the numerator has a higher power of x than the denominator. And we want to split these up into fractions. We don't quite just get fractions like this. Because what we can do is we can actually divide this numerator by the denominator and get something like this, which isn't in fraction form. So when we do the top divided by the bottom, we'll get something x plus something, and then we'll have something left over, which couldn't be divided a whole number of times. And it's that other bit that we use to make these two fractions. So that might sound a bit weird, but once we've gone through this example, hopefully that will all make sense. So the first thing we want to do is, because it's a fraction, we can actually divide this top bit by the bottom bit. So here I put this whole part, our numerator, inside here, and I'm going to divide the whole thing by x squared minus x minus 6. Yeah, so we're going to do this just like we would do with any remainder theorem. So kind of algebraic division, basically. So for this, 2x cubed divided by x squared would just be 2x. So I pop 2x on the top. It doesn't matter where you put it on here. I like to put it above the x term, but it doesn't really make a difference. Then I'm going to multiply this 2x by all of these. So 2x times x squared is 2x cubed, times minus x is minus 2x squared, times minus 6 is minus 12x. So we then draw a line under here, and I subtract everything. So this take away this will cancel out. Minus 3x squared take away minus 2x squared is kind of like adding the 2x squared, sorry. So that will just become minus x squared. And then these two will cancel out because they're the same. So I would always put 0x. You could leave it blank, but I think it's harder, so I'll just put 0x. And we pull down the minus 11. So this is the same as any remainder theorem or algebraic division. It's just a tiny bit more complicated because you've got 3 terms in front rather than just 2. Then we repeat the whole process. So minus x squared divided by x squared is minus 1. So we put minus 1 up here. And I multiply minus 1 by each of these. So I get minus x squared plus x and plus 6. And again, I then subtract all of these. So these will cancel out. 0 take away 1 is minus 1, so we get minus x. Minus 11 take away 6 is minus 17. And that there is our remainder. So it's important that you're really comfortable and really understand what we've done just here. So what we've just said is that this bit here, our numerator, divided by our denominator, gives us 2x minus 1, remainder minus x minus 17. So importantly, this minus x minus 17 is a remainder. So this bit hasn't been divided by the x squared minus x minus 6 yet. Just to give you an example, it's kind of like if we did 26 divided by 5, and we found out that the answer was 5 remainder 1. Yeah. So 5, when in 26, 5 whole times, just like in our case, we got this here, went into our numerator, 2x minus 1 times, but there's a remainder of 1. In our case, the remainder is minus x minus 17. So this bit hasn't been divided by the denominator yet. So we just get rid of that. So once we've got all this, the next thing we need to do is write out the answer by what we found. So we've just found that this divided by that is 2x minus 1, remainder this. And when I say remainder this, basically this bit here has not yet been divided by the x squared minus x minus 6. So if I want to write it all as one equation, I have to put this bit over that. That's a really important thing to understand. And then the whole deal with partial fractions is it's this bit here I need to split apart using partial fractions. So if we do that now, I'm just going to copy this down to here. So we got minus x minus 17 over. And then rather than using this quadratic, I can actually factorize that into 2 brackets. So that will give me x plus 2 and x minus 3. Yeah, so I just copied this down, but I factorized the bottom. Because remember, if we're going to split something into partial fractions or split something into fractions, we need separate factors on the denominator. And that is then going to become our c over x plus 2 plus our d over the x minus 3. And hopefully this is making sense. If we look back to what they wanted, we have ax plus b, and we know that bit there is the 2x minus 1. So we know we're going to get 2x minus 1, and now we just need to find the c and the d. So that's basically what I've tried to do here with the c and the d. Okay, so then, just like normally with partial fractions, we multiply everything by the x plus 2 and the x minus 3 to cancel them out. On the left, I'm going to get minus x, sorry, that's not very good, minus x minus 17 equals c sets of x minus 3 and d sets of x plus 2. And now I can start plugging in values to try and figure out what these things are. So perhaps to cancel out this term, I'll let x equal 3 first. Yeah. And so on the left, if x is 3, I have minus 3 take away 17. So minus 3 take away 17. And on the right, this will cancel out. But 3 plus 2 is 5, so I'm going to get 5d. So I have minus 20 equals 5d, which really just means that minus 4 equals d. Yeah, so we've now found out what d is as well. So if I scroll back up, I could put minus 4 here. We know that d is going to be minus 4. Okay. Then, to find out c, I need to cancel out this term. So I'm going to make x minus 2. So this bracket becomes 0. So now let's let x equal minus 2. Over here, minus 2 minus 17, minus 2 minus 17. And then here we have minus 2 minus 3 is minus 5. We've got minus 5c. And that tells us that minus 2, take away 17. Oh, sorry, I made a little mistake there. So if x is minus 2, and I have minus x, the minuses will actually cancel out, so I get positive 2. That's my bad. We've got 2 minus 17, which is minus 15, equals minus 5c. And so we divide both sides by minus 5, find that 3 equals c. Yeah, so up here, we now know that c here is 3. And so now I just write all of this out in one go. So our overall answer means that the answer is 2x minus 1 plus 3 over x plus 2 minus 4 over x minus 3. And that's it. This is A, this is B, this is C, and this is D. So I hope that all made sense. Hopefully having these steps helps a little bit as well. But the main thing to remember is you first of all actually divide the numerator by the denominator, and you see what answer you get and what remainder you get. The answer you keep as it is, that bit's done now. But then with the remainder, you need to put that over the same denominator and then split it up using the partial fraction technique. Anyway, I hope that all made sense. If you have any questions, let us know down in the FAQ. And otherwise, have a go at the next video to kind of practice and consolidate all this stuff. Thanks.